this lesson, you'll learn how to determine probabilities using permutations and determine probabilities using combinations. How can combinations be used to form committees? The United States Senate forms various committees by selecting senators from both political parties. The Senate Health, Education, Labor, and Pensions Committee of the 106th Congress was made up of 10 Republican senators and 8 Democratic senators. How many different ways could the committee have been selected? The members of the committee were selected in no particular order. This is an example of a combination. An arrangement or listing in which order or placement is important is called a permutation. Ms. Barraza asked pairs of students to go in front of her Spanish class to read statements in Spanish and then to translate the statement into English. One student is the Spanish speaker and one is the English speaker. If Ms. Barraza has to choose between Jeff, Kathy, Guillermo, Anna, and Patrice, how many different ways can Ms. Barraza pair the students? They showed the problem with a tree diagram. So you can see that if the Spanish speaker is Jeff, then the English speaker could be any of the other 4. And they showed the sample space using one letter for each person. And conveniently, each name started with a different letter. That was handy. Now, in general practice, we're not going to want to take the time to write all of this out because it would take all day. It's going to be faster to realize that if we choose one of the 5 first, it's not going to be the same speaker again, so there are 4 left to be the English speaker. So 5 times 4 is 20 choices. So in this situation, we took 5 students and chose them 2 at a time. The general formula for permutations, the number of permutations of n objects taken r at a time, is the quotient of n factorial and n minus r factorial. So in this problem, we had 5 factorial, which is 5 times 4 times 3 times 2 times 1, over 5 minus 2 is 3 factorial, which is 3 times 2 times 1. And of course, anything divided by itself is 1, so 5 times 4 is 20. So if I want to find the permutation of 8 things taken 4 at a time, I've got 8 factorial over 8 minus 4 factorial. I'm going to write it I'm going to shortcut myself this time. 8 times 7 times 6 times 5 times 4 factorial, because anything divided by itself, even 4 factorial, is 1. So what I have left is 7 times 8, which is 56, times 6 times 5 is 30, which gives me a product of 1,680 ways that you could pick 8 things 4 at a time. I don't think we want to try to make a tree diagram for that. Shaquille has a 5-digit passcode to access his email account. The code is made up of even digits 2, 4, 6, 8, and 0. Each digit can be used only once. How many different passcodes could Shaquille have? Okay, without using the formula for permutations, we know that the first time he picks a number, or she, there are 5 choices. Then they've used 1, so there are 4 left. Then they've used 2, so there are 3 left, and so on, which is the definition of 5 factorial. And of course, 20 times 6 is 120. Using the permutation formula, we could write 5 factorial over, and they're going to use all 5 digits. So it's 5 minus 5, or 0 factorial. So 5 factorial divided by 0 factorial, how many ways can you use none of the numbers? Well, there's exactly one way you can use none of the numbers. So 0 factorial is 1. So again, we get 120. Same problem. They want to know what is the probability that the first 2 of his digits of his code are both greater than 5. Well, of his digits greater than 5, there are only 2 of them. In our numerator, if it's greater than 5, where our choices are either the 8 or the 6. So if I use one of them, then I have one left. And then I need 3 more digits, so I have 3 digits left that are less than 5. Once I've used one of them, I need to subtract 1, and our total sample space was 120. When we multiply, 2 times 6 is 12 over 120. Probability is still favorable over total, reduce, and we get a probability of 1/10. An arrangement or listing in which order is not important is called a combination. For example, if you're choosing 2 salad ingredients from a list of 10, the order in which you choose the ingredients does not matter. The number of combinations of n objects taken r at a time is the quotient of n factorial and n minus r times r factorial. Customers at Tony's Pizzeria can choose 4 out of 12 toppings for each pizza for no extra charge. How many different combinations of pizza toppings can be chosen? The order that pizza toppings are added does not matter, so this is a combinations problem. So we're just going to plug into the formula. Combination of 12 things taken 4 at a time is 12 factorial over 12 minus 4 would be 8 factorial times 4 factorial. To simplify, 12 factorial means 12 times 11 times 10 times 9 times, okay, I'm going to get lazy and stop at 8 factorial because I have an 8 factorial in the denominator that I know can cancel out. I'm going to go ahead and write 4 times 3 times 2 times 1 for that guy. Okay, we said the 8 factorials will cancel out. 4 times 3 is 12 will cancel out. And the 2 and the 10 can cancel that much. And 55 times 9 is 495, which was choice A. That is a lot of choices for pizza toppings out of only a possible 12. Diane has a bag full of coins. There are 10 pennies, 6 nickels, 4 dimes, and 2 quarters in the bag. How many different ways can Diane pull 4 coins out of the bag? Okay, so the coins, it doesn't matter when they were minted or what state is on the coin. It's still a combination problem because it doesn't matter which dime you pull out first. So we have a total of 10 plus 6 plus 4 plus 2 is 22 total. So we're going to have a combination of 22 taken, and there are 4 different types of coins, so 22 taken 4 at a time. So plugging into the formula, we've got 22 factorial over 22 minus 4 is 18 factorial times 4 factorial. And again, 22 times 21 times 20, 19, and I'm going to get lazy and stop at 18 factorial because I have an 18 factorial there, and 4 times 3 times 2 times 1. Okay, the 18s are gone. 4 will go into 20 nicely, and 3 will go into 21, and 2 will go into 22. So out of a bag of 22 coins, there are, multiply that out, 7,315 ways you could pull out the coins. Out of the same bag of coins, they want to know what is the probability she will pull 2 pennies and 2 nickels out of the bag. Okay, once again, it does not matter which 2 pennies or which 2 nickels she pulls out, so it's combination. So I have combination of 10 taken 2 at a time and combination of 6 taken 2 at a time. And we're going to multiply them together using the fundamental counting principle to get our total. So they like that combination formula so much, we're going to use it twice in the same problem. So the combination of 10 things taken 2 at a time, we've got 10, which is our n minus 2, so 10 minus 2 is 8, and r. And again, n is 6, n minus r, 6 minus 2 is 4, and r. Then I'm using that little trick of stopping with my 8 factorial, so those cancel out, and the 2 and the 10 will cancel. So I've got 45 there, and again, the 4 factorial cancels, and the 2 and the 6 will cancel, so I've got 15. So there are a total of 675 ways we could pick out 2 pennies and 2 nickels. So our probability is 675 out of 7,315. Well, they both end in 5, so at least we can divide by that much. So we reduce and we get 135 out of 1,463. It'd be nicer to put that as a decimal, and when we do, we get about 9%. That's a little bit more understandable. In a permutation, the order of the objects is important, and we have a formula for that. In a combination, the order of objects is not important, and we have a formula for that.